Hi, okay, so let's start talking about analytics, in particular big data, and what that means to us when we're looking at analytics for defense and security. This presentation here, I'll go through this again. This is one of those where I want you to read it on your own time and kind of get the highlights out yourself, and remember that. But we'll go over some of the key elements here. The first thing I want to talk about is this may be obvious to a lot of you, but to a lot of folks, what exactly is big data? Because there's a lot of talk about it. And there's a lot of talk that maybe isn't necessarily useful either. So we're going to go through some of the key elements here. By definition, it's extremely large data sets that can be analyzed computationally to reveal patterns, trends, and associations. So think about this as all the sales figures over the last 10 years. All the flight records from an airline over the last 10 years. All of the flight data recorders, terabytes of information that comes off of an airplane when it lands. Terabytes of imagery from a satellite that might be flying overhead. These are things that historically you've been unable to keep them on data on computers and such. But now, because we have these huge amounts of data that's available to us, or huge amounts of storage rather that's available to us with solid state drives and all these clouds architectures and such, now you can keep all this stuff. So what do you do with it? Well, there's new computational methods to actually go and sort through all that data and find useful trends and patterns and interactions with it. So this all emerges from discussions about the availability of these data sets that were too large, so large that they can't be used effectively with existing tool sets like SQL and those kinds of things. Too big to be distributed across most of them. You just spend too much time normalizing all the data into tables and rows that you'd never actually get to it. So a lot of this is what we call unstructured data. So it's just piles of data there. You don't really know how it's formatted, but we have the data there. So to do anything with it, you gotta have these sort of take it as it comes technologies that can just take those big data sets and pull meaning out of it. So yes, it's kind of new. In the sense that, a lot of these underpinning technologies have evolved to let us move in this direction, but it's really a result of a number of changes that I talked about. Increased usage of the internet, some new bandwidth. I mean, we have technology and bandwidth now that allows penetration for some of this for home users. Significant availability of storage, new tools for indexing, multi-core processors, a lot of things that combine to let us look at a lot of these big data challenges. Why is it important to intelligence? Well, one, because there's an internet presence. So now, all of a sudden, everything that's going on the internet, we can actually sort through and start to figure some of this stuff out. ISR, your intelligence, surveillance, and reconnaissance, imagery, communications, any of these SIGINTs, any of these INTs that we talked about earlier are generating huge amounts of data. Now we have technology to actually go through that data. Other intel, same kinds of things. Big data allows us to validate our analysis. So now when we posit analysis for the kind of stuff that we've done with modeling and sim in the last week, now we can go back on all the data and say, is it real? Does that actually play out in terms of our hypothesis? And then build new methods based on what we see in the past, which then allows us to do predictions. We can actually look at all the data in the past and then start to make some predictions about what we're going to see in the future. That leads us to three main levels of analytics. You look at this big data and you say there's descriptive analytics, predictive, and prognostic. Descriptive means we can look at all the data coming off this device, or all this data coming off this imagery, and describe what happened. Okay? That's huge. That's important. All right, from a forensic perspective. But what we really want to be able to get to is predictive. If we know what happened in the past, we ought to be able to predict what's going to happen in the future based on, rule sets and algorithms. So that if certain conditions exist, we can predict carefully that this is going to happen. Prognostics is what we want to get to the next layer, which is then if we can predict it, then I can build in machine learning to actually act on it ahead of time. So predictive may be an alert that goes to somebody saying, hey, guess what, this is going to happen and that's going to happen. Go do something about it or prepare for it. Prognostic actually sets in motion the actions to do it. So from a supply chain perspective, let's say, predictive says you're going to need these parts and tells somebody. Prognostic actually goes in the supply chain and orders the parts already before we even know they're needed. That's machine learning, that's artificial intelligence, all that stuff wrapped into there. It's not science fiction, it's real. It's happening on a day-to-day basis. And it's happening in a lot of environments, and we're trying to get it into intelligence and security as well in the various places where it makes sense to happen. So here we talk about Department of Defense. We got ISR. What do we mean? We've got video feeds, right? Following key targets. We don't have enough analysts in the world to manage all of the target collection that we're doing and all the video collection that we're doing. So you've got to have machines that can do the processing on the imagery, look at what happens over time, the relationships, and then make some alerts and do some tipping and queuing of analysts to say, look, there's a lot going on, but here's something that you need to be interested in. Here's something we should go look at. All that in real time. Change detection, same kind of thing. If I got all this imagery coming off satellites, I don't have enough analysts in the world to actually process all of this and see what's being changed from a ground perspective. But our change detection algorithms can go through now and say, hey, looks like there's automatically all that data. There's some changes here that you might want to look into. Intelligence community, other things within the IC, communication alerts, who's talking to who. If we tag certain people, the machine can actually tell based on the timing of some of these communications if something's going on. Especially when you start talking about commercial transactions. Certain things tend to happen in patterns and trends that if we can identify those automatically, then we can send alerts to people to look in a little closer at some of these areas. Arms control, same kind of thing, surveillance, phone, video. All of these things, when you think about all of the data that you can possibly capture and building algorithms on top of those, you start to see the value that big data can bring for you. Basics of operating on this big data problem. Typically, like I said, it's not going to be structured data. You can't load it all into a database and then start doing queries and pull it up on a little screen like you would an ordering system or something like that. There's an indexing process that you'll usually go through for each of these data sets that'll let you sort of tag it and then do multiple passes on it. But there's a lot of copying these data sets so that you can actually do questions on it. And you build these tags that basically say this is the kind of data that's associated with this person, or this is the kind of data associated with this particular weapon. And then once you have those tags, then it gives your machine a little bit of smarts to go through and then build you queries for it. You need more storage really than you have source data. So as big as it is, you're going to make it bigger probably when you start querying some of these things. So when do you use this? It doesn't mean that you can do everything with it. It does still only solve certain problems. It has a cloud architecture is the key sort of underpinning architecture for a lot of this stuff. Seriously, multiple servers tied together in such a way that they allow sort of 12-factor applications to run on them. That's what a cloud really is. Some people joke to say a cloud is if you have the server, it's a server. If someone else has a server, it's a cloud. That's not really the case. A lot of cloud architecture means that any program that's developed with 12-factor principles can go run in Amazon Web Services. It can go run in Azure, Microsoft. It can go run in other cloud environments. And that allows you to sort of be very portable, very mobile with your technologies to go ask questions, because all these little applets are going to be asking questions. There's huge amounts of data that can't be fit within an SQL database. So if you can get someone to just run a bunch of servers and farm, and you can run your application anywhere on there, that's what the technology that you need. So if that's the kind of situation we're in, this is where you kind of use a big data problem. If you need to bring different data sets into the store and there's no time to normalize everything, that's going to be, when you use cloud architecture and big data. Anything with tagging, store and forward operations, translators, those are the things when you should use it. You should not use this kind of technology for rapid answers. This isn't the kind of query response system where you put in a medical record and comes back with the results. That's not what this is for. This is for search. Think of it in terms of search, right? You go into Google something, it comes back with everything it knows about that problem set. It doesn't really structure it in the way of a perfect answer, but it gives you everything that you need to know, to start moving forward with a response. Sometimes we can structure those things in a way that it will return perfectly useful capabilities, but it's not great for displays either. You don't want to back end any displays that are required with a cloud architecture. That's not the kind of thing it does. It does have some issues too as well. A lot of data sources are not solely owned by anyone. Lack of structure can lead to volatility, in the format and in the source location. You've got some shady collection methods that can be dealt with, especially if you're dealing with the internet. As much as you have access to it, everyone else is going to have access to it as well if it's on the internet stuff. If it's DoD ISR, then you're dealing with the sources. But if it's not, then you got to realize that whatever you're doing, someone else can do it as well. And if you put something on a cloud, that's a lot of data. That's vulnerable to anyone. Now, a lot of these cloud architectures are very secure. And you can do what they call on-premises clouds as well. So you kind of replicate the environment and put it in your own security environment with the same sort of architecture. But then you lose some of the benefits of being able to leverage companies like Amazon and Microsoft that can just do that very cheaply. And like everything else with resources, if you can get someone to cover the cost of the storage and the management of data, then that's more resources you have to go put into the analysis side of it. So these are all trade-offs that need to be made. It should be recognized that anything that can be collected on the internet by our government can also be collected by other governments. So just something to keep in mind there. You make some practical decisions when you're deciding what you want to store and what you want to capture in terms of data. And this is kind of important to think through. There's a lot of people that will say, look, just keep everything, and then we'll go look at it later. That's not necessarily the best approach. Practically, you want to know what are the priority relationships that you want to be able to correlate. How much data is really enough data, and what are your best quality sources? You want to understand who's vetting the quality, and are we getting the sources from the right kind of places? Because if your data is junk, then it's not helping you to have a bunch of big data out there if you can't rely on it actually being useful or true. From a technical perspective, you want to think about if I'm collecting all this data off of aircraft, off of imagery, where am I actually going to store it? Because if you're going to download it off of a camera or off of a device on an aircraft, terabytes of data, you got to be able to move that back to where the analysis is done. Sometimes that means you need to do the analysis on location, right, on premises or at the forward base. Sometimes that means you need to transfer it quickly to some other place where they have larger collection sets. These sound like trivial kinds of things, but it's actually big architecture decisions that need to be made in terms of how we set these ground stations and other sort of elements of the overall system up, so that we can better take advantage of the big data. A lot of times what we'll do is we'll translate stuff over time, so you get this huge data store, back office data store that you can do a lot of analysis on, and as they develop rules, they'll ship the rule sets out to the smaller stores that are on premises or at the forward base, and so they can start operating tactically with the rules and still developing all the rules back at the wherever the home location is. Lots of mechanisms here. I'm not going to go through them, but think about all of these kinds of mechanisms that are going to capture a lot of data and store that off and allow you to look at it later to try to figure out trends and opportunities. Anything you can imagine being collected is being collected. Anything that's discrete can be correlated with other discrete data. You can look at weather and see if that is impacting your overall supply. You can look at communications traffic and then compare that with a completely different data set related to purchasing or related to some MASINT that you're collecting as well. All these things by themselves may not say anything, but when you combine them, they may tell you a story. And that's what big data really brings to you. Commanders in theater will always tell you they got a lot of video, they have no intelligence. And what they mean by that is they don't have enough people to act on it. This is where big data and the technologies can help. We are still limited, though, in how fast those relationships can get developed and implemented. How fast can these programs to look at this stuff actually get built? That's going to limit you. You're limited still in how fast computers can operate all of this. Just because we can store terabytes of data doesn't mean we can process through it as quickly as we need to make rapid decisions. That's why rule sets are important, because you can deploy rule sets back into smaller sets of data and let tactical operations and decisions be made on a more rapid basis. Thus, we might have a lot of data being collected from different sources, but you might still have lack of funding to actually act on it. And so keep in mind that this is still not a panacea. It's a great approach and it's a great tool to have in our toolbox, but we've got to be able to implement it, architect it, implement it, and utilize it as effectively as possible. That's all.